Hello, grade 11 students. I hope you are having a great day. I am Teacher Kat, welcoming you to another fun-filled and exciting learning experience in general mathematics. For today's episode, we will be exploring the concepts of inverse functions, and you are expected to represent it through its table of values and graphs, then find its domain and range. So, are you ready? Please make sure that you are in a comfortable place and you have with you your pen and paper, or probably your cell phone with your GeoGebra app. Now, join me with an open heart and mind as we conquer this quest. Before we proceed to our main topic, let me check first if you can still remember the previous discussion. Question number 1. When do we say that a function has an inverse? Very good. We say that a function has an inverse if and only if it is a one-to-one function. So, what is a one-to-one function? Perfect! The function is said to be one-to-one if for any values of x of 1 and x of 2 in the domain of f, there exists an f of x of 1 is not equal to f of x of 2. That means the same y value is never paired in two different x values. I hope you are enjoying while actively listening, and I understand how excited you are to learn new concepts. So, we will now have our lesson. Please get your pen and paper and let us make a short activity. Are you ready? Great! Now, let's consider the table of values by the given function f of x equals 2x plus 1. The x values are negative 2, negative 1, 0, 1, and 2, while the y values are negative 3, negative 1, 1, 3, and 5. Now, interchange the values of x and y of the function f of x equals 2x plus 1. You might have arrived at this particular table of values. Does the table still represent a function? Why do you think so? Yes, the table still represents a function. We see that even we interchange the values of x and y, it still represents a function because each x value is associated with only one y value. And by interchanging the values of x and y in the given table, we get the inverse of f of x equals 2x plus 1. Now, let us graph the given function f of x equals 2x plus 1 and its inverse. On your paper, using the table of values for the given function f of x equals 2x plus 1, plot the points on the coordinate plane. The table is shown on the screen. Were you able to get a graph which looks like this? If yes, then you got it correctly. Now, using the table of values for the inverse of given function f of x equals 2x plus 1, plot the points on the coordinate plane. Your graph should look like this. Observe the two graphs which we were able to draw earlier. You have probably noted an obvious observation based from the graphs. To verify it, let us put the graphs in this manner. If we put the graph of f of x equals 2x plus 1 and its inverse in one coordinate plane, we will have this figure. The blue line is the graph of the original function f of x equals 2x plus 1, while the red line is the graph of its inverse. Observe that if we draw a line y equals x, as shown by the black line, it can be noted that the graph of the inverse of f of x equals 2x plus 1 is a reflection of the graph of the original function through the line y equals x. Now, what conclusions can we derive from this discussion? We can say that, number 1, if x and y values of a one-to-one function are interchanged, the result is still a function. Number 2, to represent the graph of the inverse of the given function, we simply draw the line y is equal to x and reflect the given graph across the line y equals x. At this time, let's proceed to the next concept which we have to learn for today. On your paper, find the domain and range of the function a equals ordered pairs negative 4 and 4, negative 3 and 2, negative 2 and 1, 0 and negative 1, 1 and negative 3, and 2 and negative 5. The domain of the given function is negative 4, negative 3, negative 2, 0, 1, and 2. And the range is 4, 2, 1, negative 1, negative 3, and negative 5. Simply put, the domain are the values of x, while the range are the y values. If you were able to get the same answer, then you are doing great. Let us take another example. Given f of x equals 1 minus x, where x is restricted to 0, 1, 2, and 3. What is its set of domain and range? The table of values is shown on the screen. The domain is the set containing 0, 1, 2, and 3, while the range is the set containing 0, 1, negative 1, and negative 2. Were you able to get the same answer? You are really awesome! So, what will be the inverse of the function shown in the table? Correct! Its inverse can be represented using this table of values. How about the domain and range of its inverse? That's right! The domain of the inverse of the function is 1, 0, negative 1, and negative 2. While the range of the inverse of the function is 0, 1, 2, and 3. You are doing great today. We can therefore sum it up that the domain of the inverse function is the range of the original function, and the range of the inverse function is the domain of the original function. Before we end, let's try to extend what we have learned by considering this example. Find the domain and range of the inverse of the rational function y equals 5x minus 1 all over negative x plus 2, whose graph is shown. The domain of the function is the set of real numbers where x is not equal to 2, while the range is the set of real numbers and y is not equal to negative 5. Therefore, the domain of its inverse is all real numbers where x is not equal to negative 5, while the range of its inverse is all real numbers and y is not equal to 2. That wraps up our learning episode. I hope I have helped you in your self-learning. Please continue answering the activities or tasks provided for this class. Thank you so much for being with us today. Join us again next time for another interesting and fruitful discussion. This is Teacher Kat, reminding you to never give up and keep discovering new things. Stay safe, God bless, and good day, everyone.